Okay, good evening. Welcome to
That's number 984.
FamilyMath985a. So this is a appendix, unpublished actually, to Stephen Strogatz's book, Infinite Powers, that he just shared online yesterday. And I gave it to you, and you read. You took 5 or 10 minutes to read it quickly. Mm-hmm. What is it about, and what is the problem that's being discussed?
So it's about how to calculate the area under x to the n.
All right.
Or y equals x to the n.
So how would you do that? The area under y equals x.
So usually what you would do is you would use integrals. So you just say integral from 0. I think it was from 0 to 1.
Yep, 0 to 1.
Of x to the n dx is just 1 over n plus 1 times x to n plus 1. Just, this is kind of basic, kind of the first thing you learn from integrals. And I forgot this already, but this is kind of the first thing you learn when you learn about integrals for the first time.
Okay, and what does this mean? What is this symbols over here?
So this is just this expression evaluated at 0 and evaluated at 1.
Okay. So,
and 1 minus the 1 is 0, so it's like 1 over n plus 1. So it's 1 over n plus 1 times the quantity 1 minus 0. Because you can factor out the 1 over n plus 1 from each of the terms, so it's just 1 over n plus 1.
Okay, so if you have calculus at hand, this is
pretty easy problem.
Yeah, sure. It shows that what used to be a very, very difficult problem actually turns out to be an easy problem. But what's the difficulty, or what's the interesting thing he's talking about?
So this is just in the time of Fermat, which was before calculus. So he didn't have this type of thing.
Right. So he didn't have all the power of calculus. And before we move on to what Fermat's idea was, before you learn integrals, what's the idea for how you might, if you can draw 1 over x plus 1, just draw something.
Just one of these.
Okay, and so what is the idea from calculus that gets you to those integrals?
So the idea is that you chop it up into rectangles, and then you calculate the area of the rectangles, and then you get smaller rectangles, and smaller rectangles, and smaller rectangles. It doesn't matter too much if you go over or under, because as you get smaller and smaller, it will eventually approximate the area.
Okay. Cool. And hopefully you find that your areas converge. Okay. What did Fermat do?
So Fermat did...
You don't have to describe it perfectly. We'll flip through it. But what did he do before calculus was invented?
So he did the same general thing, but instead of rectangles with equal widths, he made the widths into a geometric series. So it was kind of going in like this.
Okay.
Like that.
So,
and then he was able to calculate this. And then he was able to calculate these as a geometric series.
Oh, neat. Okay. So he used rectangles of unequal width. Okay, so yeah, we I don't think when we were doing calculus last year we even ever did a single example like this. So cool. All right, so let's see if we can understand what went on in the paper. Do you have any questions before we dive into it?
No.
Okay. All right, let's see what came next.